Well, probably, I mean.
Shall I?
Yeah, so this is the record crowd, by the way.
Yeah.
Oh yeah. So trust me, I'll show you pictures.
Okay, let's go ahead and get started. Good afternoon, everyone. First, I thank Professor Uzair to let me introduce Scott Morrell. So we're doing a little change because he's a very good friend of mine. So let me start with the formal presentation of our speaker first. Scott is a Director of Commercial Airport Services for Applied Research Associations, or which known here in town ARA. He currently serves as a Technical Lead Manager for a portion of the support of contract for the FAA Airport Technology Research and Development Program. Prior to joining ARA, he worked for the Port Authority of New York and New Jersey as a Chief Civil Engineer. During his 33 years experience and career with the Port Authority, he led the engineering of numerous airport, roadway, and support paving utility evaluation and design projects. So that's the official presentation. So I'm going to add a couple of words here. I've known Scott for a number of years now. We work together in the ASCE in organizing conferences. We're organizing one in next year also in Philadelphia. And I can tell you, I know that the student's going to meet with him after the presentation. He's the kind of engineer that I consider is an idle engineer. He has the ethics. He works with very, very high standards, working with him on technical and non-technical things. I can tell you, this is the person that you want to meet and you want to learn from. I can tell you, I treasure his friendship. We fought a lot, actually, too, but we both support each other in getting things done when we were at the ASCE. So it's indeed my pleasure to have Scott with here today. So the floor is yours.
Okay. To get started, I want to start with a shameless attempt to curry favor with the crowd. So go Cubs. Until next spring when the Mets start playing again. And then, I'm, you know who I am from the introduction, nice introduction from Ahmad. It's also been my pleasure to know Ahmad these years and work together, and I have a lot of respect for Ahmad, and I've gotten to know Hassan the last few years, and it's been a pleasure working with him, both, again, with the ASCE. It's really been fun. So my presentations, I call it real world runway engineering. As I mentioned, I was the chief civil engineer of the Port Authority of New York and New Jersey. I am no longer employed by the Port Authority of New York and New Jersey, so that's kind of the disclaimer here, talking about engineering and not about the Port Authority. Just to start out, this is kind of, I've seen this kind of stuff at TRB. You do an outline of your presentation, so here it is. So covering really all aspects of runway engineering practice today. And what I'll be doing is, when I was with the Port Authority, there were two major runway reconstruction projects. One was done in 2010, the other was completed in 2015. So I'll be referring to those projects as I go through the presentation. So some background. To some, you'd call it a sad fact, but the fact is there aren't many new runways being constructed in the United States nowadays. Very few, runways added. So what we have really has to be its use. We have to get the most out of it. There's a lot of pressure to keep runways open, and when you do have to work on them, to get it done quickly. The other thing is, so because of not many new runways being constructed in the U.S., really the name of the game here is rehabilitation and reconstruction. That's what the practicing engineers, most of them work on, if it was just new runways, there wouldn't be that many engineers working on airfields around here, because it doesn't happen that often. So the two runways that I'm going to talk about are the orange runway, which is 13R31L. That was constructed in 2010. It's over 14,000 feet long, so a very long runway, especially at sea level. Longer runway would be in Denver. That was built not that long ago, in the last 10 years. And then this 4 left, the runway in blue, 4 left, 22 right. Both heavily used for departures from Kennedy. So some more background. So things are changing in the airport environment. This kind of, well, it almost spans my career at the Port Authority. I started in the 80s and walked out in 2015. And you could see what's been happening to tire pressures. And that, in my opinion, it's influencing pavement performance. Okay, there's some people, that would be some controversy. The asphalt industry might tell you otherwise, but my opinion, it does have an impact. Next slide. And the other thing that's going on is you get a new aircraft, and then there's derivatives. And it's one of the things in practice you find is that when a new aircraft's introduced, everybody's looking at it and seeing how it fits in and how it'll work. And then there becomes like, say the 737. Well, there was a 100, a 200, a 300, a 400, a 500, a 600, 700, an 800, a 900, and then the next generation. It's 737, right? Well, it's not really, because you can see what's happened to the wheel load on the 727 over that time. And in addition, the tire pressure has gone up on that vehicle. So the wheel loads and tire pressures that you see on 727s today, when I started doing this back in the 80s, would have been on a 747. So now we're taking, so you've taken that kind of load and putting it on airports all over the country. So let's go into conceptual planning. So to start, for conceptual planning on a runway engineering project, well, really nowadays, with most projects, it's really starting with pavement management, because that's kind of setting up your timeline. Now, some organizations will do PCI evaluations. That's really probably the most common things. Organizations like the Port Authority will get some additional information. They, when I was there, they would do FOD, some kind of FOD potential evaluation. And then they also collected a lot of profile data and did roughness analysis in addition to PCI collection. Now, one of the important things is, in the case of the Port Authority, they started doing PCI investigations back in the 1980s. So over time, they had a lot of data, and they could start to develop some pretty good predictive curves on what was going to happen. So this is from years ago for 13R, but so in 2007, an inspection was done on a runway. And then here was the projections going out. So the policy of most airports is to maintain the PCI on runways about a 70, where it's still considered in good condition before it drops into fair or acceptable condition. So the idea here would be that by like about 2009, you would want to be in construction on the runway. And that's what happened on this project. But this started in 2007. They said, we got to be out on this runway in a couple of years. And what are we seeing on the runways? Well, this is a picture of some of the, where you're getting some shoving, which this became very problematic at Newark International Airport. It's something we struggled with for a couple of rehabilitation cycles. What I should say is the Port Authority airfield pavements, the vast majority of them are asphalt surfaced today. every runway prior to 2010 was asphalt surfaced, except for maybe some end areas. So a lot of experience in that agency with asphalt. So here you can see where the grooves were moving on the surface, and this is from runway 4 left, 22 right at Newark. We got to the point where we had to resurface the runway after like 8 years. We weren't even getting 10 years anymore out of the surface on the runway. The other thing with HMA is, and this is pretty common, you know, with all the paving joints, and even though paving in echelon, where you have two pavers going down simultaneously, so you have a hot joint, some of that's done, and then you would have maybe a cold joint further out on the runway outside of that center keel area of the runway. Well, you would see this kind of progression where you start out with a crack on the cold joint, and then you get that secondary cracking, and then you run the risk of foreign debris digestion by foreign object debris, FOD, which can get ingested into an aircraft engine, and that's like the big nightmare of any airport pavement engineer is FOD.
Is that a concrete pavement underneath, or?
Now, this is Newark, so this is the lime cement fly ash, probably about 8 inches down, Marshall, at this point with overlays and resurfacing. So, all right, so we started out with, we knew we had to do some kind of rehabilitation. Traditionally, it would be, we would go back in, mill off the surface and do some kind of overlay. Maybe mill off 3, put back 4 inches, do a little grade correction for the cross slope, and go from there. But now we're getting to the point where we saw that the runways, and with the combination of what the traffic loads are, that we were seeing runways that weren't lasting 10 years. To resurface a runway at Kennedy Airport during nighttime closures was a 2-year endeavor. There are 4 runways at Kennedy. If you're only getting 8 years out of the pavement, you're always down a runway, because as soon as you finish the last one, you're back on the first one. So we started to look at ways that we can break this cycle. So now the other part of this was, so we said, okay, we're in rehab, we're looking at rehab, but now we're seeing the A380 aircraft came online, and the 747-800 came online. And there's an engineering brief that the FAA issued, 65A, which says if you're doing major rehabilitation on a runway, that you should increase its width. This runway was 150 feet wide, it should be 200 feet wide. So now we have a project that went from a rehab, but also we need to put some full depth pavement on the edges. So that was kind of pushing the project into, we need to close this runway not just for nights, but an extended period. So that kind of entered into this. But we realized we needed to rehab the electrical system, there was drainage improvements, we had to resurface the runway. We were looking at a major rehab. The assessment by the agency at that time was that we need to widen this runway to 200 feet. This was the second runway at the airport that was being widened to 200 feet. There was one that was done previously with an asphalt resurfacing project. So then the next thing that came up on these is in general, sometimes the guidance that you get for FAA about separations and clearances, just like the dimension of the runway had to change, well, there are runway safety areas. So ideally, or I don't know if I should say ideally, but the standard is that you would provide 1,000 feet beyond the end of the runway that would be basically kind of graded, an open area that if a plane overshot the runway, it would end up in this area. But that's not practical at every location. These runways have been in existence for 50 years. So the engineered material arresting system was developed to allow for some protection in shorter areas. So if you just heard about the vice presidential candidate Pence's plane, it ran off the runway at LaGuardia, I guess last week, and went into this engineered material arresting system to keep it from going on to Grand Central Parkway. So that, the whole point of this discussion is you need to have these safety areas. So the preferred, let's put it that way, the preferred safety area is to have the 1,000 feet. So in the case of runway 4 left, there was an opportunity to adjust the runway to get the 1,000 feet. So that was also something else to look at in this project. And that could affect, again, whether you were doing, you'd have to do some closures or operationally shorten the runway, which can be a problem at JFK because of the long-haul Asian flights that they need the runway length because of the fuel load and the passenger load on takeoff. So there was, the whole point of this is it became, the scope was kind of moving from rehab to do this widening, to do this additional safety area improvement. So it was all growing under the conceptual planning phase. Then finally, a lot of the major hubs are facing delays, right? You hear, I'm sure, local Chicago, probably there's talk about delays at Chicago too. In fact, I think the modernization program, a lot of it was to untangle runways to decrease the amount of delays at Chicago, is my understanding from like the public press releases. So another thing you can do is, since a runway is almost like a machine processing aircraft. Come in, get them on the ground, get them out, right? You go out there, you spend time at a major international airport, and it's just kind of like watching an assembly line. One in, one out, all right? So one of the things you can do is, if you can get the planes off of the runway quicker, you can help with the efficiency of that machine. So during planning, what they'll do is they'll run a simulation of the runway, and they'll play with the location of the exits on the runway for arrivals. So with that, you can optimize the performance of the runway. And that's part of things. We're not adding more runways. We have to get the most we can out of what we've got. So one of the things is, what you can get into is start putting new taxiways connecting to the runway to improve the efficiency, get the planes off and on. So as kind of leads right into this, so this became the scope of the project during the conceptual design for both projects, pretty much. So some type of resurfacing, the widening, the additional taxiway entrances and exits for to reduce delays. And then we had new drainage system, regrading, new electrical infrastructure, some widening of existing taxiways, threshold relocation, so that's where the runway physically begins, and you can see those with the markings. And then on 4 left, the safety area work. So that became the scope. So then we looked at 2 alternatives. So we looked at whether we should do it in hot mix asphalt paving, which we had traditionally done, or we should do some PCC paving, because we knew with the widening and the additional work that there was an opportunity. If we had to close, that PCC might be a viable option. So we did 3 things as part of the conceptual study, at least the engineers in part. So we did a life cycle cost analysis. We looked at construction staging, and then duration, which is all critical, all part of the decision process. It's not all just figuring out how thick a pavement is. There's more to this. So at the time, we were looking at it. We felt if we were doing a hot mix asphalt rehabilitation, that it would require a 9-inch overlay for grading purposes to make it work with the widening of the runway. And then we would come in on basically an 8-year cycle. We were feeling at that time that we would have to come in and do kind of mill and overlay, and then really 8 years out, and then the alternating year, we'd have to do something a little more than just a 3-inch mill and overlay, a little more for the rehab. And this was kind of based on in the past, we probably would have put 10 years against this, but what we were seeing at Newark kind of led us to go to 8. I don't know, somewhere in that range based on my experience. And then we looked at the PCC. We still need to do, because there's a lot of asphalt surface taxiways adjacent that would get within the runway safety area, so it would still impact the runway. So we'd still have to go and get some of those. And again, we kept the short cycle, even though it might not be as tight. You know, the runway, you would probably be, you know, it could go down to 8. Most likely not for most taxiways. You can at least get 10. But this is kind of conservative. Add some cost to the PCC. And what we found in the case of 4 left is we found that the going in and doing a Portland cement option was 15% more than the asphalt option, but over the life cycle it was 12% less, and that was based on a 3.5% discount rate. And then for the earlier project, it was closer. The initial costs were closer together, and then it turns out the life cycle cost was 36%, based on 40-year life. This wasn't based on 20-year life. What you'll find is, to date, the FAA standard is designed for 20-year life. They've done some studies where what they found with most of the concrete pavements is they were getting well over like 35 years on most of them. So we didn't think it was a stretch to use 40 for this. So, and then then we looked at the construction duration. So in the case of asphalt, you have the option of doing nightly closures. We've done this all along. So if you got nightly closures, it would be basically from 10 p.m. to 6 a.m. was what you could get at Kennedy, which was a little more than what we would get at LaGuardia, which would be midnight to 6 a.m. So you could at least get 8 hours, but of course then you have to mobilize, to get out there every night, and then you have to button it all up before you reopen operations. But you could reopen operations. But as you can see, we estimated 24 to 30 months to get the construction done with the asphalt doing nightly closures. But if you're going to do staged full closures, you could still do it for asphalt. You know, if you're going to close for concrete, you could close for asphalt. And we had done this before. At times, we did 40-day closures at Newark Airport to do resurfacing projects, and even shorter. We did like a 3-week closure once and resurfaced one of the runways. Fortunately, it was one of the runways that only lasted 8 years after construction. But so for stage full closures, we found that the construction duration was pretty much comparable. And what we found, and we had confirmed with some peer review, was that the airfield lighting replacement is the critical path item for a major paving job. So, which I didn't realize going in. So there was 2. So in the end, we had estimated 18 to 23 months for either one of those options. So then we took a look at how to stage it, and this is for 13R31L is shown here. And in that case, there was an opportunity, since the runway was located next to Jamaica Bay, so there was nothing beyond it. So the runway could be fenced off and really made a part of the land side of the airport. You have an air side and a land side. So the air side, you require escorts and special handling. But there was an opportunity to bring in, to fence in off the end here and bring construction equipment in and materials to do the construction. So in the case of this project, it was there was some sub-staging, but it was fairly simple. It was basically 3 main stages. So the bulk of the runway, roughly 12,000 feet of it. Then this, the intersection with 4 left, 22 right, which was a critical location because now you're impacting 2 runways. And then the east end of the runway, the 31L end of the runway. So it seemed feasible. Now, we got to this point, and then what you do is you have to go and basically you have to go in and sell it to the airlines. You know, you don't just run an airport. The airlines have a lot of say on what's going on. They pay, you know, flight fees and rent and whatnot to these major airports. And they rightfully have some say in what matters. So we went out, did some outreach to the airlines, explained what we wanted to do. They offered some comments, but they agreed with the approach, and they endorsed this selection of concrete for this project. And it ended up both projects. But the initial one in 2010 was the first one where we were going back and putting a concrete runway in. So now, so that's kind of the conceptual part of it. Since it's a rehab, there was no environmental assessment or impact required. Did go through the process for a finding of no significant impact from the FAA, FONSI, and that applied to both projects with some tweaking at times, but in the end we did have a finding of no significant impact. And I apologize when I say we, because I was with the Port Authority 33 years, and I still slip into that every once in a while. So here's runway. We'll go through the design. So this is the overall for the runway. So let me get into it in a little more detail. So at the north end, what I have here is on the left, I have a slide that shows the pre-2014 condition at the airport, and then in the blue and orange, it shows the new runways and taxiways. The blue is asphalt surfaced, and the orange is PCC surfaced. So on the north end, there's a whole reconfiguration, and you can see the runway extends a little bit to, which was part of the runway safety area work. But you can see there were 2 entrances on the north end, and now there are 3 new entrances. There's a reconfiguration south of the intersections with 13R31L. And as we go through the bullets here, so yeah, there's the main runway reconstruction, and then there's this whole queuing area. Some of this work, the reconfiguration of ENCA, is south of the intersection, and then the runway is extended 735 feet, and then we did some partial reconstruction on 13L31R in that area, that other runway crossing, just to set things up for the next runway project if the agency decided to widen that runway to 200 on the next rehab cycle. For the center section, it's basically some tweaking of the exits again to help with the delay reduction, and then the main line paving. And then on the south end, the decision was to surface taxiway K, which is the one paralleling the runway, all the way down with PCC because of the queuing that goes on as they're loading up. And then this is this area on the, I don't know if this, oh, it does work okay, not so well, but there's a holding apron down at the end of taxiway K near the end of the runway. That was asphalt surface, concrete surface, which we ended up overlaying with asphalt. It's every once in a while you get an aircraft coming down to the end there, and they need to check something out or run up their engines a little bit before they go off. And that area, for grading purposes, we had to go in and do an overlay on it. So. For the cross-section wise, so the runway's 200 feet. Then we had 80 feet of shoulder and what we would call at the Port Authority erosion pavement, which was just basically a blast pavement outside the shoulders, because with the outboard engines on some of the wide bodies It was an issue with, we couldn't maintain grass in there, so we're blowing stuff around. So what we end up is a 360-foot wide pavement box for the runway. Okay, let's talk about the pavement design a little bit. So, this is a bad slide because it gives you the final product ahead of time. I shouldn't use that. So, so this is what JFK International Airport started as. It was Idlewild Airport prior to the assassination of John F. Kennedy, and it was marshland that they had pumped sand from the bay in hydraulic sand fill. And so what you've got there is a poorly graded sand, which would be an SP classification. And over the years, this was 1940s, so by 2005, we kind of knew what we had out there. So we basically had something where design CVR of 10 was giving us good results. So that's what we were dealing with in terms of the subgrade. Now, and then what we had here was in the 1940s, the runway was originally built with 12 inches of Portland cement concrete on 6 inches of stone screenings. In the 1970s, when 747 aircraft were introduced, we started overlaying it. They have like a thick overlay in the 1970s. And then over the years beyond that, you can kind of see it. Maybe you can't where you are, but you can see lifts in that a little bit. And, come back in, mill some off, put some back. So what you can see here, just on this slide, you probably can't read this, but it's actually 17 inches of asphalt is what that tape measure reads on that. On top of that, and this was a very successful approach. Worked from had this pavement in service from late 1940s through 2009. So did the job. So this is what we're dealing with the existing section. So now this is what we're looking at with the aircraft. So Dr. Rosler was showing me something today where 400,000 movements on the taxiway at O'Hare. So this I think I kind of tallied up. It's a little over 100,000 movements for this runway. So this is for 4 left, 22 right. Now, when we had done the earlier design, it was an earlier version of Farfield. So it was a limit of how many aircraft you could put in, and so we had to kind of do a lot of combining. So A320s and 737s kind of got treated the same, and lumping and grouping. So it got a little better by the time we did the next design. And so with that, but we still did some grouping. We didn't put every type of 737. We kind of made them all, a couple of the more modern classifications. But here you can see. Now, at the time of this design, we didn't have an idea what the A350 was going to be. But which, if you don't know it, I mean, they're talking 254 PSI tires on that thing coming up in 70,000 pound wheel loads. So that's coming. That's significant. And it's out there, but that derivative hasn't arrived yet. I don't think they're flying it with 250 PSI tires yet. So here you have the aircraft mix that was used in design, because basically with Farfield you need to know what your subgrade is and what your traffic is. And when we did this analysis in Farfield back in 2000, I guess the first time was probably in about 2008. We had to go through all kinds of machinations to do this design. We were assuming everything to figure out how to treat this thick overlay on top of an existing concrete, and we happened to know some of the people at the tech center who wrote the program, so we would call them and we were getting their advice, and we kind of analyzed it like 4 different ways at that time, and we didn't have to do any of that. By the time this time around, we just kind of went in and ran the analysis, and basically we came out with an 18-inch pavement. When I used to give this presentation, portions of this when I was with the Port Authority, I always go through this whole analysis where we treated the asphalt as this, we added thickness to the underlying concrete, it was all kinds of things, and in the end they were all kind of hunting around 18 inches, which 18 or 20 always seems to be the answer at Kennedy. So I'm a little suspicious. I think you just get to a point where you have so many movements that you just kind of hit a thickness that's okay for everything after a while. Okay, so some of the unique things on this job. So Port Authority wrote its own concrete specification. The Port Authority has its own materials lab led by a gentleman by the name of Kaz Bignacki, very talented materials engineer, good with concrete and asphalt. And under his leadership, they developed this specification. So I always, size 357 aggregate, if you don't know it, is pretty damn big, okay? Pardon my language. So that's why the truck next to the piece of, that is a piece of aggregate from the job. So, but some of the requirements, Port Authority was always believed in allowing for incentives for quality construction. There's an option in the specifications, FAA specifications, you can go over 6% over the cost for quality materials. But the Port Authority, in adopting it, decided, well, we're not just doing it based on strength. And I think you've probably learned in some of your classes here, it's not all about strength, it's about durability too. And so there were some additional requirements about making sure that the drying shrinkage test is performed on the mix, so we weren't getting a mix that was going to contract a lot. We had a limitation, so it's 40% slag. And cementitious not to exceed 5,500. We had a permeability requirement on it and a water cement ratio. You had to be within air content and water cement ratio to qualify for the incentive. So some of the stuff was on the mixed design, but then when we're in the field, we're doing microwave testing, checking air, as always, but it meant something, because if you didn't get it, if you weren't controlling your mix, you were going to get hit. You were going to lose your incentive. And these guys, with this mix, it was pretty easy to get an incentive, you'll see, going forward with the results. All right. I've been talking a lot about concrete, but there was a heck of a lot of asphalt on this project also. So it was performance graded. 7622 was used within the stripes of the taxiways, and then there was for say the shoulder areas, which there was a lot because we were raising the grade, and I'll get into that. We used some 7624, so 5.2, 6.2% AC content, and pretty much at times during the Port Authority, we were using 3/4 inch nominal maximum aggregate size, and the gradations were kind of on the coarse side. So the results sometimes were not so great with the workability. So in the end, we backed off to a 1/2 inch, still what we would call a stone-rich design for the asphalt, but and that's what I believe they're still using today, but they were using it as of the time that I left the Port Authority. So, okay, let's talk about the intersection. All right, so this is in the context of the first job to go, which was that 13R31L. So So the challenge was when we ended up designing this for grades, we were raising the grade a foot on the runway, which is something where I guess you'd love to be able to do at O'Hare or maybe on some projects. And this was quite unusual for us, right? But here's the thing. So we had it raised a foot, but we're crossing another runway a foot higher. And we weren't paving the other runway at this time. So how do we handle that? So what we did is we pretty much have a practice. If you break the grade going into the intersection about 0.5% every 25 feet, you can pretty much work out a pretty smooth transition. But we had worked with a consultant at the Port Authority, and it was APR, which they're a niche firm that really gets into this smoothness, especially airfield. They have aircraft simulation programs. So if you look at the FAA has a tool, Pro FAA, it has a 727 in that. Well, APR can do a 737-800, which I had always found to be kind of like the canary in the coal mine, as old expression, where the miners would bring the canaries in, and if there was gas, the canaries would die, and they knew to get out, they would die first. So the 737 was kind of the one that I found that if you started, that was the first one to feel if there was roughness on the runway. It was sensitive. So they could do 737, and then he could also do 747. So we'd always check that to see if there was anything, maybe in a longer wavelength that 737 would have hit that 747 might. So we took the design and ran it through the simulation just to check it. The idea being that we would not want to keep the response at the pilot station below 0.4 G, the accelerations. So we're hovering there, but for most part, we're pretty good. So what the consultant did for us is they replaced the actual measured profile on the runway and then just put in the graded grades that we provided and ran the simulation. So we thought, okay, so that seems reasonable. You know, this isn't going to be a permanent condition. It's going to be until we do the next runway, and then we're going to do something else to help smooth this out. So that was kind of something I think it was a little unique for us to do as part of the design process. Oh, and I should make it clear that the Port Authority staff, the design for these two runways, the civil engineering design, was done by in-house staff. So it wasn't that we were hiring a bunch of consultants. We did use APR to run this check for us because they do this specialized simulation work. But the electrical design was done by consultants for the in-pavement lights and whatnot. But the civil engineering was all designed by Port Authority staff, a very talented staff. Okay, now this one I always have to sigh. So this is 4 left, 22 right. And so what you see on the left is the top half of the runway and the right is the bottom half. This is the staging plan for the runway. So when you're working in the real world, okay, this can have a great impact on your efforts. I mean, the amount of effort you have to do to get a design done. So there were a million meetings and each of these little stages and when they could be worked on under this project, this was, as compared to the other runway, which was pretty simple, this was a really tough effort to get this. Because now we were in an area where we had we had runways and taxiways on both sides now. We had the easy one. We only had to deal with one side. Now we had the more difficult one, and we had to get, and certainly we couldn't impact on the runway further to the east, 4 right, 22 left. So this is how the staging worked out, and staff were a little worn out by the time they got this staging done. And my advice to you, again, from my experience in the real world, is you do all this as a designer, don't fall in love with it, because when they get it in construction, I would bet you any amount of money that that was not followed to the letter, that things changed in the field. But that's providing the framework for the contractor to bid, to put his price on it, that this is, this is what you have to deal with. Okay. The other thing is you may get involved with is special contract provisions. So one of them can be damages for delay. All right. This is something when the airlines gave their input, this is where it was. They're like, okay, you can do this, but we're adjusting our schedules to accommodate this work. It has to be done when you say it's going to be done. So, and this is the stick that they wanted in the contract. So for the intersection, okay, started out, I think it was $3,000 for the first 15 minutes you're late in getting done. Next 15 minutes, $4,500. Next, $6,000. And then, go from there. And then different ones, $300,000 per day, goes from there. So big time incentive to get things done on time. Okay? I had mentioned quality incentives. That's kind of an option with the FAA specs, okay? But this is funded by the airport and not by the FAA, this incentive. So that agency said, yeah, we want the quality incentives, okay? Then the other thing we did, and I was an advocate of this, was additional compensation for early completion. Basically, when we said, well, what's an appropriate number? Somebody asked me, what's an appropriate number? I said, well, use 6%, because that's what we use of the cost to the project. So it was basically, does it add up? So this is, actually what's shown here is not 6%, but that was what we started out with the discussion. But basically, they could get $10 million in additional compensation for completing early on these projects. So what that does is it encourages the contractor who's got their act together, who can do good quality. It's kind of the helps where in a low bid environment, if you can provide something like this, you'll get the contractor to invest in new equipment for the job or extra resources to make sure it gets done. Okay, so let's go to the construction. How's my time, Hassan? Where am I at?
You are maybe another
5 minutes? Okay, that's good. Construction slides always go fast. So I'll take you through the fall. This is real quick. So just some initial stuff. It started, there's one project started in the fall. It's funny, both of them always started in like the third quarter. So, so there was a concrete plant on site, brought in a lot of material and kind of, so here's the on-site batch plant, material stockpiles. They did electrical dump bank and drainage. So, and then this is kind of unusual. We had an 800-foot long test section for the project. We took a taxiway for the project, and I'll show it again later probably, but it was south of the runway. It was kind of off on its own. We used that as the test section. So we wanted everything just like it. We put grooves in it, even though it wasn't required, just to make sure we had every operation that was going to go on. And then we had a post-test section, kind of lessons learned, moderated lessons learned session. It says right there. Okay. And there was the test section. So you see, big. This would be a project some years for us. A taxiway, project would be 800 feet at times, new taxiways. So then they did some electrical work during the winter, and then they ended up closing the runways at night, so they took out the lighting ahead of the final closure, and then they had full closure on March 1st, 2010, and then the first stage, which was like that 12,000 feet, went through to June. And as you can see here, they finished 1 day ahead of schedule for that work. And that was important because then we could, that section of the runway could be reopened for use. You can see some of this. We had some fiber reinforced concrete on the one end of the runway that we removed. That's what you're looking at there, was kind of in the keel section. There's a lot of milling.
What was that big pulverized net concrete stuff? What is that?
I forget, you know, because I had never seen one before that, and that thing was a monster to get that fibrous concrete out. But I forget what that's called. But that was some operation. That took a while to get that out. If you really need to know, Marshall, I'll track it down. Okay. I know you might be thinking of something. Okay. So, and then there's a milling operation, some electrical work. Here's the light cans going in with the reinforcing around them. Those are just jigs holding them in place for the infill work. Okay. So the book will tell you that you should, underneath this pavement, you should put a bond breaker. Okay? So took a little gamble on this and said, our concrete is very strong, doesn't shrink a lot. So we're going to go with, we're going to take the milled surface and whitewash it with curing compound and pour right on it and not put a bond breaker in. So, and that's what we did. So you're looking at that milled surface, which, by the way, so that was the first project. When we were doing the milling, we had some areas where the interface with the next lift let loose, so it kind of peeled off. So we had to do some kind of like take an asphalt sand mix and do some patching, because this really wasn't providing a lot of strength to the thing, to the pavement section, so a little bit wouldn't really impact anything. So we decided, actually with the second one, is we over-milled slightly and put 2 inches down. But for this one, we were trying to save operations, so we're like, we're not going to do a paving operation on this. We'll just mill it and spray it and go to town with the slip form. All right, so transverse dowels, probably overkill with what's underneath this runway. So slip form paving, compound, you guys probably see it. So there it is going out. So big runway. Putting the dowel bars in. Line up. All right. So some of the infill paving. You have the shoulders. I mean, you could tell it was a big asphalt paving operation because it had the trailer. They were trailering in the asphalt, not just using conventional insulated dump trucks. Okay. Be a quiz later. Everybody look at that. Remember that truck. Okay. We used some artificial turf. I saw some up at O'Hare when I came in yesterday. So for some of those areas where you can't just keep the grass, there's too much blast. All right. Then into the summer and fall, I got to wrap up quick. So basically, paved the intersection and then moved east of the intersection. Everything was completed on time. The incentives did their job. Here's the results on the intersection paving, which was, actually it worked out better than what we anticipated. By the way, so this is, what you're doing now is this profile's run on the intersecting runway, so it's not on the one under construction. It was on the 4 left, 22 right that was in place. So it ended up, the ramping to grade, transition grade, it was overall was 1,350 feet long to keep the response where it needed to be. So this was the measurement afterwards on the intersection. So it worked out. as a finished runway. So here are the quantities. See, 325,000 tons of asphalt on a concrete job. Okay, so 55 miles of joint seal. Okay, so that was the quantity, and this is from the 13R 31L. Quality. So on that one, so the average flex roll, right, with less 550 pounds of cementitious, so 1105. Okay. Standard deviation is 92, so all good. Smoothness was good. We actually had Tony Girardi go back and do his smoothness thing, and if you've ever seen, APR, that's who Tony Girardi is, the principal. And what he always said, he always had this thing, this was the smoothest runway he ever, the green was the smoothest runway he ever measured. And he went back and he did this one, and it came right down there. Grade control was really good. So good grade control, good strong material, you know, everything's great, right? Everything's great. Uh-oh, right? What happens, right? We got a lot of this. Okay, this was not good right after it. We were getting a lot of joint fraying. We had a beautiful job, and we had some of this happening all over the place. We called in the paving associations. We were talking, why did this happen, right? Best thing we can come up with is that truck you saw, that off-road vehicle working on it, there was a lot of, they were using the new pavement as a construction highway. Everything was going on in this pavement, all right? So that was one of our lessons learned coming out of it. I went and actually presented this problem to the American Concrete Paving Association at one of their meetings. I asked to come down and talk to them about this. So we said, we're not having this again. We didn't really have any, they went back and patched it. There's questions about how long these patches worked for these partial depth spall repairs, spall or the fraying. Some of them we didn't bother patching. We did some stuff with some kind of filler and whatnot. And actually it's worked out from what I understand in talking to people at the Port Authority recently. It seems to still be performing okay, but this is not what you want to see after you go to all this trouble of putting in a concrete runway. So we took lessons learned out of this. We applied it to the next job because this was 2010 and we were back out there in 14. So what we did is we added some contract language that if we got over a certain percentage of the perimeter of a slab with this kind of effect, slab comes out, all right? The other thing we did was we went to bevel joints had started being used in between, so we went to a bevel joint on it. So, and we did not end, of course, we put all kinds of language about not allowing construction equipment on the pavement, you know, and keeping the pavement clean and everything. And that appeared to work. So you can see, you can go through all these things in the end, and one little thing can impact your job. And as a design engineer, you know, it's always really tough when you have this vision of what you're going to get, and you walk out and look at the reality, and sometimes, you know, it can be a little disappointing. So, but I have to say, you know, with this instance, I mean, it was corrected, and it wasn't the entire length of the runway, but it tended to be more on the east end of it. So I'm way over, aren't I? I'm done. So I can try to answer questions. I'm batting about 500 on Marshall.
Yes.
For the ground that you have to the joints of concrete that you said that maybe the truck maintenance problem. Could you come up with some temporary roads, some secondary roads for a year or two, just solve this problem?
Sure.
Only.
Yes, that's absolutely right. You can use, there was existing shoulder pavements. It was just, there was kind of a security patrol road adjacent to the runway. There were other options than riding down the new pavement to move equipment from different parts of the job.
Those rubber tires?
So that one was, it was just a big dump. Yes?
I find it interesting that the pavement broke under the construction equipment, but it's being designed for planes. Is it just the different loading patterns?
Well, it's also you're tracking things like stones and stuff, so you're getting like little point loads, and also if you're on it before you get it to kind of its final condition of the joint, you're hitting that edge, anything where you're getting on that edge, Now the bevel joint, they kind of more came up with for northern areas for snow plowing operations to keep you from, but it seems to have worked to help with this also, and it looks really good in the field when you see this. I was still working for the agency when the top section of 4 left, 22 right was repaved, so I was out there walking around just before I retired from the agency. Yes?
How quickly did that volume here?
Oh, I would say within 6 months of opening. So, excuse me?
You'd already accepted it.
No, we still had retainage. So we got them back, and the construction management division. By the way, the Port Authority has its own. I mentioned its materials lab. I mentioned we do the design. We also have a construction management division, which is, so a managed job of this size. It was led by Port Authority engineers, supplemented with consultant staff. So it was kind of a nice agency to work for because we had kind of expertise across the board, and we did a lot of stuff ourselves. Yes?
Was used? Was it preformed?
Yes, it was
Joints?
preformed.
And he's also asking about the type of the patch or filler material that was used in the joints.
The
Type
which,
of the patch or filler material that was used.
for the spalls?
Patch
For the
or the
joints.
filler material. The filler material that was used.
Yes.
Is that for the joint?
For the joints.
For the joint? Did
For
you
the
use filler
repairs.
or?
For the repairs.
No, there weren't. I'm trying to think. Only a little bit on the isolation joints. So for like the contraction joints, everything was a slot and preformed, right, neoprene. And then for those, like where the taxiway hits the edge of the runway, you have to do those isolation joints. So that was just an asphalt impregnated fiberboard, and then on top of it, we didn't have great experience with silicone, so I think it was just hot poured rubber for those. Yeah,
Hot poured asphalt.
yeah.
But the preformed was neoprene, right?
Yes, neoprene, yeah, yes. And we had a lot of experience with that on previous taxiway jobs and whatnot. We had about 20 years experience with neoprene and good
It's
experience.
performed very well, but
Yeah.
it's very expensive,
Yeah,
right?
yeah.
Any other
But as a
questions?
percent, it's not that expensive.
It's not that, yeah.
By the way, these jobs were both in the, it was like $200 million, a little over $200 million to do the one runway. The other one, actually the shorter runway, the 4, was more expensive. I think that might have been up. I'd be guessing, but it was more than the $200 million. Yes?
So this type of jobs, for example, the contractor, is it just one contractor or is it sort of a consortium of different contractors? And how did you define, how did you assign the contract to?
The low bidder was Tudor Perini, and then he would bring in subcontractors for like the electrical, the in-pavement lighting work. And then things like the grooving, the sawing, those were all like subs, and it's probably more than I'm thinking.
Some sort of certification for the Port Authority or the FAA, or it just depends on their overall experience?
What we did was we pre-qualified the contractors, so so there was a submission involved with that, and for the most part, when I had been involved in pre-qualification of contractors before this, it was more just like financial qualifications almost. But I had advocated on this that we include some definite like experience, like showing that you could do, we hadn't done any, we did like one slip form paving job that I was there 33 years. Before this one, we did one, all right? And it was the south end of the runway at Newark, and that was it. And it was like 10 years before it, right? So we went in, we wanted to show that, you had the experience doing runways, working in the runway environment, certain production rates, that you could do so many cubic yards of concrete placed, per day. So we added that into the pre-qualification statement. So.
What we can do, actually, I think we have the meet and greet session.
Okay.
Because we are running really way over our time.
Okay.
We can continue interacting with our speakers. In the interest of the time, I think I want to thank Scott one more time. This was an excellent presentation.